Hello, this lesson is on zeros of polynomials. Before we get started, I just wanted to review a little bit about roots. Remember, roots are same as zeros, and that's what would make the function equal to 0. So in this particular case, my two roots would be -5, because if I plug that in for x here, -5 plus 5 is 0. I would have -5 here as well, which would make that -8, but I'd have 0 times -8, which is still 0. So one of my roots would be -5, and the other one would be 3. And then just a quick note about factoring. When I factor a quadratic like this, I need an x here and x here, and I'm looking for two numbers that multiply to be -40, but also add up to be -3. So in this case, that would be -8 and +5, because -8 times 5 is -40, and -8 plus 5 is -3. So just a reminder about factoring. We're going to have to use that today. Okay, so zeros of a polynomial. These are your solutions. This is where the function is equal to 0. They're also known as roots. So we had talked about this before. Roots can be real or imaginary. We haven't really talked about in this class. We probably won't really get into imaginary roots, but there are two possibilities there. You can have real roots or imaginary roots. If you take pre-calc, we'll talk a little bit more about the imaginary root part. Okay, so if I gave you these, excuse me, these three graphs, and I said, what are some things you notice? You might notice that when I set these equal to 0, that happens to be my solution, right? So my roots here would be 1 and -2. And you'll notice that is also where these cross the x-axis, or where y is 0, okay? Same thing over here. I've got a -2, you can see that. And my other root would be 1. And this time there's an exponent on that, and instead of crossing the x-axis, it does something else. It looks like it kind of bends back away from it. And then over here, I've got -2 and 1 again. This one just kind of does something weird at 1. It looks like it sort of bends around there. And this one just crosses like normal. Okay, so we're going to kind of analyze those things a little bit more deeply. All right. So the zeros can tell us how the graph is shaped and vice versa. If I know how the graph is shaped, I can know a little bit about the zeros and what's going on there. All right. So if the graph or the line passes straight through the x-axis, we have a multiplicity. Now multiplicities are when we have this. So when I have a squared here, that means really that one of my roots is 1, but it occurs twice. So I really have x equals 1, and then I have another one, x equals 1. That happens twice. And then my other root would be x equals -2. So we say it's a multiplicity of 2 for x equals 1 because there's 2 of them. So over here, this would be a multiplicity of 3 because I would have x equals 1 3 times. Okay. So if the line passes through like it does right here, okay, maybe, there we go, right there, passes straight through the x-axis, then the multiplicity is going to be 1. Okay. if you get a situation where it bounces off the x-axis, so like here, where it goes up and then bounces away, if it bounces, what it really means it really means the multiplicity is even, but for our purposes, it's probably going to be 2 or 4 because we're not going to get that big. Probably most of the time it's going to be equal to 2. But it really, when you see a bounce, it really is an even multiplicity. And then if you see it bend, it's odd. So that would be like this 2 here. It bends. For us, that means it's odd. But generally for us, that's going to mean 3. Because we're not going to get to functions really that are going to be so big that we're going to have 5 or 7 for a multiplicity, probably. So probably when you see pass through, it's a 1, bounce, it's likely a 2, and a bend, it'll be likely a 3. But technically, it's even or odd for these two. Okay, so this is a 7th degree function. And because we know that it's a 7th degree function, I should have 7 total exponents, really. And so I know a little bit about one of my roots right here that passes through. So that it's -4. So I'm going to write then this as a binomial, x plus 4. This also passes through. So that would be x plus 3. Okay. This one bounces, it bounces at -1, so it would be x plus 1 and then squared. And this one here at 2, so we're going to write x minus 2, it bends, so then it has a multiplicity of 3. Now if I look at the exponents, I should have a total of 7. I have 3, 2 more is 5, plus 1, because the exponents are really 1 there. So that is a total of 7. So even though we didn't know what this function actually was, this is actually what the function would look like. We could name it, let's see, f of x. And if I multiplied all that out, I'd have my polynomial function. But I could also type it into the calculator like that, and it would look like this. So just by looking at that, knowing a little bit about how graphs behave for polynomials, we can determine the function, which is kind of cool. All right, given this function, find each of the following. Okay, so we're going to sketch the end behavior. So first of all, we want to think about what the degree of this polynomial is. Well, how many exponents? I got a 1 here, a 1 here, and a 1 here. So it's odd. And it's a degree 3, right? Odd. And my leading coefficient is right here. It's positive. So if you remember from last time, my sketch would be like this. One goes down the end, the other one goes up. If it's odd and leading coefficient is positive. So it should look like that. My zeros, okay, my zeros are what makes this function equal 0. So for here, it would be 0. It would also be, this one would be 2. And this one would be 3. Okay, so when I graph it, it should cross at 0, 2, and 3. Or it should touch the x-axis at those spots, or bend or bounce one of the, right? So to determine how the graph passes through the x-axis for each 0. Since all of the exponents are 1, I know according to this, they should be passing through, right? So that's what I should have. So 0, let's write it. Actually, let's just say they all pass through. So I know that I should have a 0 at 0. I also know I should have one at 2 and 3. Okay, and then what I can do is use that information. So I want to make sure those points are definitely highlighted on there. And then it says to sketch the graph. And one of the things you can do is just graph this on your graphing calculator. So I could just type this function in and then get the general sketch, but also make sure that these 3 points are highlighted. So let's do it. I'm going to pull up my, all right, graphing calculator. Okay, so y equals x times x minus 2 times x minus 3 graph. Okay, so now if I zoom in a little bit there, I can see that it crosses at 0, 2, and 3. So awesome. So I want to sketch that. Again, it doesn't have to be perfect, but you want it to be pretty similar, and I want to highlight the zeros. So I want to make sure those are on there. Okay, so let's do that. Okay, so pretty good. You probably have a little bit easier time with your pencil than my my graph here, but okay, that's how that works, and that's really what you want to do. Sketch it, but make sure that it's fairly accurate, especially if the zeros are marked properly. Okay, so here's another one. Sketch the end behavior. You can see that it's an odd degree function. I should go back up here and make sure that, right, this end behavior right here, does it match this graph? Yes, so we're good. You kind of want to double check that before you continue on. All right. So end behavior, I have a degree 5, so it's odd. And my LC is right, it's a 1. So again, I should have this and this, hopefully. My zeros, I have 2, 4, and negative 2. Now 4 has a multiplicity of 3, it occurs 3 times, and a negative 2 has a multiplicity of 2. So let's do 4 first. Because the power is 3, remember up here, if we look at this, if it's 3, then it's gonna bend, okay? So let's write that bend. And then negative 2 has a power of 2 or a multiplicity of 2, so that's gonna bounce. Okay, and that should match when I graph this, right? Okay, so 4, I want to plot a dot at 4. Okay, and then also at negative 2. And then hopefully when I graph this, it does do what we said. So x minus 4 to the 3rd power times x plus 2 squared. Okay. I don't know why that keeps going away. All right. Okay, and then we're gonna graph it. Okay, so now I wanna see, does it bounce? So you see you got this. Okay, and then it does bend. It does bounce at -2, and it does bend at 4. Okay, so I want to sketch what I can see there as best I can. All right. So really, what I could see wasn't the whole graph, right? Okay, but we want to... Okay, so down here, like there's some stuff missing, but we can't see that on our graph, and that's okay. So it does match with my end behavior though. It's supposed to look like this, so that part's good. And we've done it, right? So hopefully this is starting to make some sense on how that works. Okay, now sometimes though you're gonna be given functions in standard form rather than factored form. So I wanna make sure that I understand that and how that works. So we're gonna try that as well. All right, so given the function h of x equals x cubed minus 2x squared minus 3x, end behavior. Well, it's odd with a leading coefficient of 1 again. Right, that's a 1. So it should go like this again. Okay, we're gonna factor this. Now, if you'll notice, every one of these terms has an x in it, and they don't have a number in common other than 1. So I'm gonna factor out an x, and then that's gonna leave me with x squared minus 2x minus 3. Okay, so now I need to factor this. So I wanna say, what are two numbers that multiply to be -3, but add up to be -2? That would be -3, +1. Okay, so now if I set this equal to 0, right, I know what my zeros would be. They would be 0, 3, excuse me, and -1. Okay, so now we can use that fact to try to help us. Now, all of those determine how the graph passes through. All pass through the x. They all pass through because all of the exponents in the factored form up here, right, have an exponent of 1. So they all pass through. So when I graph this function, I should end up with it passing through these points. So I'm going to make a dot at each of those 0, 3, and what was the other one? -1? Yeah. So I should get something that looks like this. So let's do it. Let's try it. X cubed minus 2x squared minus 3x. Okay, it should cross at -1, yup, 0, and 3. Sure enough, it does. Okay, cool. And my end behavior does match too. My graph is not the best, but it does match. Okay, so hopefully that is starting to make a little sense. Okay, I have one more and then we're done. Okay, this is an even degree function because that's a 4. And the leading coefficient is -2. So that means it should open like this if you reference your chart. Okay. Now I'm going to have to factor this. Let's see. What do they all have in common? Well, they all have an x squared, and they all have a -2. You want to get that negative out of the front there. So we're going to factor out a -2x squared. And then that's going to give us x squared plus 3x, and then -4. Okay. So now I want to factor the quadratic. Two numbers that multiply to be -4 but add up to be 3 would be x plus 4 and x minus 1. So then setting that equal to 0, we would have 0, -4, and 1 would be my roots. Okay. So 0 has a multiplicity of 2 because the exponent is 2 here. So then it bounces. -4 passes through. And so does 1. Okay. So we want to plot those at 0, -4, and 1. Okay. So we are trying to find -2x to the 4th minus 6x to the 3rd plus 8x squared. I can just type that into my calculator, and hopefully it matches what we've got. It should be facing down in theory. Okay. All right, so let's type it in. -2x to the 4th minus 6x to the 3rd plus 8x squared. Ooh, okay. Well, the end behavior is going down, so it looks interesting there. Okay, and then it does bounce at 0 and pass through the other 2. Okay. So let's see if we can get that. Did it look like that? I think it did. I lost it, yep. Okay. But you'll notice our end behavior is the same here, right? So that does match there. And just do what you can on the sketches. Again, make sure the zeros match and try to sketch it as best you can, but you don't need to look up a bunch of points. Just make sure your zeros are in the right spot, and it generally looks the same. Okay, I hope that makes some sense. That is it. Good luck on the assignment.